Thank you for joining this lesson. We are going to continue with the study of electronics, and in this video I'll be teaching the types of semiconductors. Remember to subscribe to this channel and to also share the link with your friends. Types of semiconductors. Remember we said that semiconductors are materials whose conductivity is in between that of conductors and insulators, such that at room temperature or at zero temperature, semiconductors behave like insulators, but with increased temperature, they start conducting. Therefore, now we got two types or two major types of semiconductors, which are pure semiconductors, or rather the intrinsic semiconductors. The intrinsic semiconductors. These ones are pure materials of the group 4 elements. These are pure conductors of materials with 4 valence electrons. 4 valence electrons which form covalent bonds. So you find there is formation of covalent bonds in the structures of materials which have 4 valence electrons, or rather 4 electrons in the outermost energy level. Now these pure materials can be silicon, just to mention an example, or germanium. So we have these 2 elements whose structure has 4 valence electrons, and these electrons form covalent bonds. Therefore, you find the 4 electrons can either be lost or gained. That is why we're saying they are neither metals nor non-metals. That's why they behave like insulators at some point, and again like conductors. So these are pure semiconductors, whereby now it is strictly conduction by electron hole movement. Electron hole movement is the only means of conductivity in intrinsic semiconductors. But now we got extrinsic semiconductors. Extrinsic semiconductors. And just to give a definition, these are pure semiconductors, or pure semiconductors. Into which impurities or impure atoms have been added to enhance conductivity. Therefore, we are saying naturally, when a semiconductor is pure, it can conduct by electron hole movement, because in the other video we said that an hole with increased temperature can move across the small forbidden gap to the conduction band, leaving a hole, and the hole in return attracting another electron, and the chain continues conducting electricity. But now in this case we have extrinsic semiconductors, whereby we take a pure semiconductors and into it we add impure atoms with an intention of enhancing conductivity. So now when we add an impurity to a pure semiconductor so that the conductivity is enhanced, the process is called doping. This is called doping. So we say we have doped the pure semiconductor. It's called doping. And the impure atom added is called a dopper. So we are doping, or rather we are adding a dopper to the structure of a pure semiconductor so that the conductivity is enhanced or rather improved. Now in this case, depending on the dopper we add to the intrinsic semiconductor, we get two types of extrinsic semiconductors. Therefore, extrinsic semiconductors can either be N-type or P-type. And we're briefly going to see each of these types of extrinsic semiconductors. So an extrinsic semiconductor can either be N-type or P-type. Let's look at what N-type semiconductors are. So to obtain N-type semiconductors, let me start with the N-type. We use pentavalent atoms. E.g., we have what we call arsenic, antimony, and others, etc. for doping. So for doping, when we use pentavalent atoms, we obtain N-type extrinsic semiconductors in this way. So because we are adding pentavalent atoms, according to the name, pentavalent means that these are atoms with 5 valence electrons, which means 4 electrons from the pentavalent atom, bonds with the 4, because strictly the pure semiconductor is having 4 valence electrons. So after bonding with the 4 valence electrons from the pure semiconductor, 1 electron is left free or vacant. So this electron now is responsible again for conduction. So the electron contributes in conduction. It contributes in conduction of electricity, of course. Therefore, we are saying that we have a pure semiconductor which is having 4 valence electrons, and into it we add a pentavalent atom, which means the pentavalent atom is coming in with 5 valence electrons, and now bonding has to take place. So we have 4 out of the 5 take part in bonding, meaning that an extra electron will remain vacant, or rather free and mobile, which means these electrons now take part in conduction, and conduction will have been improved because there will still be the conduction due to the electron hole movement, and now we are adding an extra electron by the addition of a pentavalent atom. This means now, because electrons have been added and they are taking part in conduction, electrons become majority charge carriers. While holes are minority charge carriers. Therefore, in this case, electrons become majority charge carriers because we have electrons introduced due to doping, and we had electrons which are being made to move by introduction of temperature, so by increasing temperature in this semiconductor structure. Therefore, now there are more electrons moving and conducting electricity than holes are doing. And by that, because the electrons possess what we call a negative net charge, then because of this net charge now, such a semiconductor whereby doping has been done using pentavalent atom ends up being called N-type due to the negative charge of the majority charge carriers in the structure after the doping. So that is how we end up getting N-type semiconductors. I will not forget to mention that now, because the doper which is being added is the one providing the extra electron for conduction, or rather it is the one bringing in the majority charge carriers, then we call it the donor atom. It is donating the extra electron for conduction. So we say that the doper in this case, or the pentavalent atom is termed as the donor atom. The donor atom, because it is the one donating the majority charge carrier in this structure for the N-type semiconductors. Remember to subscribe and share this link.